Welcome to CS224N. Today, I'm really excited that we're getting to have the first of our guest lectures. And so tonight, today, it's really great to have Maarten Sap. So Maarten is currently a young investigator at the Allen Institute for AI in Seattle, but pretty soon now, I guess he's going to be starting at Carnegie Mellon University as a professor. So Maarten's done a huge amount of really exciting and interesting work looking at socially intelligent NLP systems. And in particular, he's had a really strong emphasis at looking at issues of social inequality, bias, and toxicity in language. And that work's been widely noticed, and he's had it covered in the New York Times, Forbes, Fortune, etc. So it'll be a great opportunity today to hear about some of that interesting work that he has done. Okay, so notes, questions. Maarten, be delighted to have live questions. So if you'd like to ask a live question, you can either hit the raise hand thing, or you could put in the Q&A, live Q or some shorthand like that, and then we can make it so you can ask live questions. If you're feeling very shy, you can still put a question in the question and answer that we can relay for you, but live questions much preferred. Okay, I think that's the only instructions, and otherwise take it away, Maarten.
Thanks. I'll just say that there might be a chance that I don't see the raising hands or questions like that, so if any of the sort of coordinators can let me know if there's something that's pressing, I can, just totally answer it as well.
But we'll do that. We'll stop you for questions.
Awesome. Yeah. All right. So thank you so much for having me here today. I'm really excited to talk about some of the work that I've done during my PhD and that I'm currently still doing. And today's talk is going to be focusing specifically on work that I've done related to detecting and rewriting socially biased language. And so I want to start with a quote from Rita Mae Brown, who was a feminist author and LGBTQ activist from the 60s, who said that language is the roadmap of a culture, and it tells you where its people come from and where they are going. And so this is a known thing that many other linguists and philosophers have discussed, that language and culture really cannot be disentangled from each other that much. And this is particularly interesting when we think about understanding how inequality or biases or hatred can manifest themselves in language. And so I like to talk about this in a framework that I call the cycle of social inequality in text. And so what I mean by that is that we know that there is social inequality between minority and majority groups in the world, for example, between men and women. And because of how our language works, the world is going to influence the way that our language patterns are different with respect to these demographic groups. And so language is inherently going to reflect existing social inequality. And this is going to, for example, show up in the portrayals of minority characters who are known to be more biased or stereotypical typically than majority characters. And this also shows up in the fact that, for example, hate speech and toxicity are mostly going to target minority groups and not really majority groups. All right, I'm already seeing some discussion. I think we're good. And then in turn, the language that we use or we read is actually influencing the world itself. And so, for example, hate speech has been shown to be able to worsen relationships between demographic groups. And we also know that the portrayal of minority characters can shape the perceptions and stereotypes that we have of those minority identities. And so there's this sort of cycle that happens. And so in this talk, I'm going to try to talk about how we can make NLP systems understand and mitigate social biases and toxicity in language. And one of the reasons, the crux of the reason why this is super important is because if any human-generated data is going to inherently reflect social dynamics and inequality. And if our NLP systems are going to be trained on this human-generated data, they need to account for these dynamics, because otherwise it can have really harmful results. And so to drive this point home a little bit more, let me walk you through a couple NLP tasks. The first big task that we can think about is conversational AI, and this is a very big task that people are tackling in NLP these days. Creating digital assistants, chatbots, things like that. And you may remember the really awful example of Microsoft's Tay, which was an AI chatbot that they released on Twitter, and it turned racist in less than a day. And this is because they didn't really account for any of the social dynamics that maybe goes on the internet or went into the training data of this model. And their bot ended up having really rude and offensive conversations in this case. Another field or subfield of NLP that has gotten a lot of attention recently is language generation, which is similar to conversational AI, but just more about auto-completing text or continuing stories or news articles. And here, if you don't account for the inequality or the social dynamics that go into your training data, then you can end up with really incoherent, mindless, but also really biased or offensive generations. And some of my own work has shown that actually GPT-3, which is OpenAI's sort of most powerful text generator out there, really can delve into toxicity really quickly. And then finally, also related to NLP, there's this whole field or subfield of text understanding, and particularly I've worked on things like hate speech detection and sentiment analysis. And here, if you don't account for the underlying dynamics that went into your data collection, your data creation, you can end up with really worse performance on minority user input, or even worse, actually biased behavior against the minority users. And so some of my own work has actually shown that for example, hate speech detection systems tend to be racially biased, and I'll talk about this in a minute. And just, this is the deep learning NLP class. So, we know that in recent years, there's been a lot of improvements in NLP tests in general, thanks to these pre-trained language models. And for the sake of this talk, I just want to highlight some of the key parts of why these pre-trained language models are working so well. So we know that they're large neural nets that are trained on large amounts of text to predict which word comes next. And they're using this thing called the transformer architecture, which is a neural network. And so their basic recipe is to gather a large amount of text data, take a transformer model, and then train that transformer model to predict basically a word given its context. And there's a trend of naming these models after Sesame Street characters for some reason in NLP, but we also got some sort of text generators that were named GPT-2, GPT-3, things like that. And we know that these models like GPT-3 are getting bigger and bigger every day, but also getting bigger is the training data or the pre-training corpora that are used to create these language models. And we started out with using quote unquote only documents from English Wikipedia, or maybe just a small set of books. GPT-2 was trained on a really large set of documents that were basically outbound links from Reddit. And T5 and GPT-3 were trained on the Common Crawl dataset, which is a really large archive of basically all documents on the internet that people could find. And here I want to pause a little bit for a second and thinking about, the fact that our models are learning language from random internet data, like what could go wrong with that? So what could go wrong and does go wrong is actually that these transformer language models are really mindless and socially oblivious. And so not only are they learning stereotypes and social biases from their training data, some of my own work has shown that they're at risk for generating toxicity really, really quickly in less than 100 generations. So if you sampled 100 sentences from GPT-3, you're likely to find something really toxic within those 100 samples. So that's really quick and a problem. And so the crux of the issue is that, as Professor Ruha Benjamin puts it, feeding AI systems on the world's beauty, ugliness, and cruelty, but expecting it to reflect only the beauty is a fantasy. And what we need is formalisms to represent and detect this, ugliness and cruelty, or these social biases, and algorithms to mitigate and avoid these social biases and this toxicity and this ugliness. And so that's what I'll be talking about today. And specifically, I'm going to talk about 3 projects today. The first 2 are going to be about detecting toxicity and social biases in language. And then I'll talk about rewriting and debiasing text with a model called Power Transformer. And then I'll talk about some exciting future directions that we can go in towards human-centric social bias detection and mitigation. So I'll start with this first work, which is called The Risk of Racial Bias in Hate Speech Detection. And this work is really tackling this phenomenon of hate speech online. And we know that this is a really rampant problem that causes people to quit social media because there's just too much hate and they can't take it. Transgender people are reporting being treated inhumanely. People of color are saying that they can't subject themselves any longer to the hate. People are quitting, and there's increasing calls for these platforms to address this issue of hate speech online. Oh, I'm sorry, I'm just looking at the questions more. Okay. And one of the issues with this is, so obviously you know that platforms are struggling to moderate this content. And one of the issues is that it's really challenging to rely on humans solely to moderate this content. There's really way too many tweets or way too many posts that are posted on these platforms for humans to just be able to sift through. Apparently, according to this source, there's 500 million tweets that are sent in one day. So there's no way that we could get humans to do this all alone. And taking sort of a community-centric perspective, like what Reddit has done, where basically you delegate the moderation to the sub-communities that are naturally created, can lead to actually hate-endorsing communities. Like if you remember the famous case where Reddit CEO stepped in and basically deleted or quarantined several super misogynistic subreddits. Okay, I'm looking at the questions. Are you more, so someone asked, are you more of a proponent for we should only feed the model good data to reduce toxicity, or we should try to filter model output, modify what the model has learned from the data? That is a good question. I think we should do both, because there's no way to say that something is inherently good and is free of biases. And it's easier to, we should be really mindful of the data still, and the decisions on which data we choose is something that I think most people tend to take just kind of lightly and just take whatever's available. And we should be thinking a little bit more about whose data it is. Are we ethically using this data? Was this the purpose of it? All this stuff. But at the same time, there's this issue fundamentally with machine learning and AI, and that is that we are trying to predict the future based on data from the past. So even if something we might not consider something biased or problematic right now, maybe in a year or two, there will be sort of new evidence that some of the stuff that we trained stuff on was problematic. So I think having a stop or a way to mitigate these at decoding time or at prediction time is also something that we should do. And I'm actually really excited about that direction too, especially as we're in a new era of not being able to train our own models with these pre-trained language models being so big. So yeah, I'm excited about that. Hopefully that responds to that question. Okay, so I was talking about why platforms are struggling to moderate this harmful, hateful content online. And one of the other things that is often overlooked is that even if we ask humans to filter through this stuff, these people that are actually employed to do this and stare at awful things all day suffer really inhumane working conditions. They're often outsourced to countries where the minimum wage is lower and the conditions are just worse. And the mental health of these people is just, it's been very documented that it's really bad. So this is a place where AI could actually help, right? And so this has kind of led to this field of automatic hate speech detection, which is all about trying to make the internet less toxic. And there's a lot of work that has come out of NLP trying to tackle this task. There's even a workshop on detecting online abuses and harms. And people are developing APIs that they can use that you can just kind of use easily off the shelf. For example, Google's sister company, Jigsaw, develops the Perspective API, which is a toxicity detection system that is being used currently to moderate the New York Times comment section, for example. And so the first thing that I'm going to talk about is that there's a big problem of racial bias in hate speech detection. And when I say racial bias, I'm not talking about bias against racial minorities or hate speech against racial minorities. I'm actually talking about the kind of bias in which a harmless greeting or a harmless tweet can be flagged as toxic when written by certain racial minorities, but not flagged as toxic or flagged as harmless when written by a white majority person. And here in this case, this is happening because our toxicity models are trained on text-only annotations, and so they have no idea who's speaking. And the issue specifically in this example is that the N-word spoken by a white person is usually considered a lot more offensive than the N-word spoken by a Black person. And so this illustrates the fact that data sets are really are ignoring the underlying social dynamics of speech, for example, the identity of the speaker or the dialect of English. And in this case, ignoring these nuances really risks harming minority populations by suppressing inoffensive speech more. And so we wanted to characterize and quantify the racial bias in hate speech detection here. And specifically, what we wanted to do was first investigate how machine learning models acquire this racial bias from data sets, and also look at sort of stepping back, thinking about the annotation task for offensiveness or toxicity, and asking what about the annotation task design actually affects these racial biases here. And you may be wondering, why are we looking at racial bias specifically? Well, the answer is that, as we know, minority populations are most often the target of hate speech compared to majority populations. And racial bias has actually been studied a lot less than other identity-based biases, and specifically gender has gotten a lot of attention in NLP. And specifically on Twitter, there's an actual big danger of silencing Black folks disproportionately. There's been some studies that have shown the cultural importance of Twitter, specifically this phenomenon called Black Twitter. And it's also a really important space for activism, for example, in the Black Lives Matter movement. However, one challenge with studying racial bias is that Twitter profiles don't actually have any race data associated with them. And so what we're going to do is we're actually going to use dialect as a proxy for racial identity. And we're operating under the premise here that there are specific lexical indicators of minority identity in language. And specifically, we're going to be looking for African American English, which is a dialect or a set of dialects or variety of English that is common but not limited to Black or African American folks in the US. And it's extensively been studied by linguists and shown to have its own grammar and things like that. And there's actually also been shown to be presence of AAE variants on Twitter specifically. And so specifically, we're going to use a lexical detector that Blodgett et al. Created to infer the presence of AAE. But again, a caveat here is that dialect and race are much more complex than this. I'm seeing a question. Is using dialect as proxy for racial identity susceptible to propagating stereotypes, especially if these lexical indicators evolve over time? Yeah, so I think I'm going to click responding to it. Yeah, so that's definitely true for sure. And I'll talk about this later as well. But focusing solely on dialect, again, in a static way, ignores the evolution that this could have, as well as we don't want to categorize people's races based on their dialect alone, and that's not what we're doing in this work. We're looking at the dialect, which we know has correlates with race, but it's also important to look at actually self-reported race as well, which I'll talk about in a second. Okay, so given this intro, let's look at some results and look at how racially biased are hate speech data sets actually. And so in this work, we focused on two widely used data sets that we'll call Twitter Hate Base and Twitter Bootstrap, which are references to how they were collected. And what we find is that there's really big racial bias in both these data sets. And so, for example, in the first data set, about half of the tweets in white aligned English, which is a label that the dialect model gives us, are only half are flagged as offensive by the annotators, whereas 92% of them in African American English are flagged as offensive. So there's a huge skew, and we see a similar skew where 18% of white aligned English in the Twitter Bootstrap data set is labeled as abusive versus much higher rates of abusive tweets that are in African American English. I'm seeing another question. Something I noticed in a lot more online spaces that people regrettably will use AAE despite not being Black, usually for humorous effects. So under the system, could trolls get away with saying the N-word by trying to put an AAE spin on it? Yeah, that's a thing that people talk about a lot, actually. The sort of appropriation of African American English, or just those kinds of things. And I think SNL called it Gen Z slang, but it really was markers of AAE that they meant. That's a broader question of how language sort of gets adopted by different groups and how things evolve in that way that I think sociolinguists are probably more equipped to talk about. But yeah, it's definitely sure that if someone is sort of adopting an AAE identity online, then they would also maybe fall prey to this over censorship by toxicity detection systems for sure. Oops, another question. Reflecting on a precision recall trade-off is classifying such problems. Which would you do recommend approach to model building? Let me talk about the results real quick first before we talk about that. So given that there's evidence in the data that there's a lot of racial bias, like we wanted to see how, do models actually acquire these racial biases from data sets? And maybe you're thinking, oh God, maybe they're actually averaging those out because they learned to pick out the right patterns in the data, right? Because models can do that, and we're really optimistic about it. Unfortunately, models actually not only acquire these racial biases, but they exacerbate them. So that's a problem. And in order to show this, we basically trained classifiers on these two data sets that we were looking at, hate-based and bootstrap. And we're going to look at rates of false flagging of toxicity. And specifically, we're going to break those false flagging of toxicity rates down by a dialect group on our development set. And here and we're going to look for bias under the definition of the equality of odds opportunity criterion from Moritz-Hart. And looking at the results here, what we find is that both data sets are really biased against AE, and specifically, they make mistakes towards mistaken AE as offensive much more often than mistaken white-aligned English. So the first one, 46% of non-offensive AE tweets are mistaken for offensive versus only 9% of white non-offensive tweets. And in the second classifier data set, 26% of non-abusive AE tweets are mistaken for abusive versus only 5% white. And the opposite is true for the second data set, where white tweets that are actually abusive are flagged as non-abusive at a much higher rate. Okay, does that answer your question? I don't know if that's what you were specifically asking about, but would you recommend an approach to model building? Yeah, so I think in this case, maybe the question will be answered later about, actually instead of thinking about model building, we should be thinking about different ways to conceptualize this task. Okay, how do we distinguish between disproportionate hate speech detection due to true positive, false positive? Hopefully those results just answered your question here. Do you think asking users for more personal details such as race is too much of a risk for users' privacy? That's an interesting ethical question. I think, unfortunately, if we want to do research that involves people, like, we need volunteers and we need people to give us information, because I think we have enough evidence that without actually, studying these problems and tackling and really digging into the issues related to identity, we're not really going to be able to make something less biased, unfortunately. Okay, let me move on for a second before I answer some more questions. But so, what we've seen here in the sort of in-domain, in-distribution setting is that there's really strong bias against AE tweets for both these classifiers and both these data sets. But you may be wondering, okay, maybe this is a data set problem and the racial bias doesn't really generalize beyond these data sets, right? Unfortunately, it really does. And so this is kind of addressing this question that I just answered about race and asking people their race. So in order to simulate, we wanted to simulate a situation where these classifiers would be released in the wild. And we looked basically at prediction rates of offensiveness when you actually have more gold standard dialect or race information available. And specifically, we looked at one corpus that had dialects inferred based on geolocation of tweets and US Census demographic data. So it's not gold, it's maybe silver standard labels. But sort of more informed by where the tweet came from. So the dialect label might be a little bit more valid. And what we find is that one of our classifiers basically is twice as likely to predict that an AE tweet is offensive compared to a white aligned tweet. And then we also looked at another data set where people actually participated in a survey online, gave researchers their race as well as their Twitter handle, and they gave a bunch of other demographics too. And those researchers then sort of scraped all their tweets and to study, I don't remember what the purpose of this study was specifically online, but we can use this data set to actually see, regardless of dialect, what is actually happening when we look at self-reported race. And what we find, unfortunately, is the same kind of biases that are there in dialect land. And the classifier here is 1.5 times as likely to flag a tweet by an African-American person as offensive compared to a tweet by a white person. And unfortunately, this is basically the exact same pattern in the second classifier that we studied, where, basically this is showing that not just AAE tweets, but also tweets by Black folks are more often flagged as toxic compared to tweets by white people or in white aligned English. And this is really strong evidence that this racial bias is really generalizing to other corpora here. Let me take a minute here to answer some questions. Okay. In the past, there are cases where companies saying that their model is biased because the data is biased, but it seems impossible to have perfect data. It just seems that right now we have no one taking direct responsibility on the biased, toxic, problematic models. Do you think there's a practical way to address this? And in your opinion, should the burdens fall on researchers working in the area of bias detection, all NLP researchers, or companies that apply the models, or the society where the data comes from? This is a very astute question. Let me think about this for a second. So I think one thing that we forget with these systems is that AI isn't just operating in a vacuum. It's operating in a full societal pipeline between users and government and like laws and companies and stuff. And so a lot of times, researchers are like, oh, well, I don't really know, I'm sort of turning a blind eye to how my systems are being used. But like, in order to really address like fair and equitable, like I'm just going to use this example of like toxic content detection, like it does require like, rules and laws and sort of a full pipeline, involvement for tackling this. So it's not necessarily like, yeah, maybe the companies that are applying these models are the ones that should be held responsible. I'm not really sure in terms of that, like where the responsibility should lie, but I think that we should have, operating under the premise of a democratic government, we should have, legislation that actually dictates like what can and can't be suppressed or removed through these algorithms. And I think currently the situation is that the companies have all the power to do whatever they want. And I think that's led to a lot of frustration from a lot of people. And so the answer might be that, other companies that are, more inclusivity, designed with inclusivity from the get-go could be a solution there. But yeah, this is probably a longer question to answer directly.
There's a live question, so let's have a second go and see if we can get someone to ask one live.
Can you hear me?
Yeah.
Mm-hmm. Okay, wonderful. Yeah, I'm wondering, of course, I don't know if these models are open about how they operationalize the term toxic or hate speech, but I'm curious if you have any insight into that, because that seems like not only do you have the issue of, making the model accurate based on your rule set, but also defining a rule set, because different people, like the NAACP, would say that the N-word is never acceptable. Other people, other Black people may feel differently. So it seems that there's also even within that model, a level of interpretation.
Yeah, for sure. I totally agree. And I think that, again, like kind of pointing forward to the rest of this talk, like I always advocate for like just not having AI systems determine offensiveness, period. And just moving towards like other approaches to doing this kind of problems. So yeah, let me keep going a little bit and maybe answer some questions after that, if that's okay. Okay, so we know that there's a lot of racial bias in these classifiers, and it just seems really bleak. So, you probably are all wondering like, okay, what can we actually do to reduce these biases? One answer is that actually changing the way that we do data collection helps. And so to test this out, we did a small sort of MTurk pilot study where we took 350 AAE tweets from our 2 data sets stratified by toxicity label. And we asked 3 annotators to look at each tweet. And specifically, we wanted them to answer a question about how or whether this tweet could be offensive to anyone. And we did sort of ABC testing, basically, where we had 3 conditions in which people were labeling these. The first one, the control condition, was them annotating just the text of the tweet, no context, no nothing. The second condition, where we basically provided them with information about the dialect of the tweet. So we were like, oh, our AI thinks that this tweet is in African-American English, basically highlighting the fact that this may come from a user who was speaking African-American English. And we see here that there's actually a significant decrease in the likelihood of labeling these tweets as offensive to anyone, which is really interesting. And then a second or the third condition that we had was basically, instead of thinking about the dialect, we made people think about the race that is associated with the dialect. And so our priming text was basically like a Twitter user that is likely Black or African-American tweeted this thing. And here again, we see a significant difference based on compared to the controlled condition. We also asked a second question of offensiveness, which is this tweet offensive to you? Which is a different sort of labeling. And one of the interesting things here is that the labeling, the propensity for people to label a tweet as offensive to anyone is much higher than labeled offensive to them or to themselves. And also here, we found that the only difference in decreasing sort of offensiveness to themselves is if we highlighted the race associated with the dialect and not just the dialect itself compared to the control condition. So this shows that, priming annotators to think about dialect and race can actually influence the labels and maybe mitigate some of this bias. But also just even using two questions, we can show that the annotations of offensiveness are highly subjective, like the mental processes that the labelers are going through are very different. So to quickly give some takeaways of this work, overt toxicity really backfires against racial minorities if we try to automate it. And we showed specifically that there's really strong dialect-based racial bias, likely due, we hypothesize that this is probably due to like the negative perception of race in AAE. It's just sometimes thought of as like less good English or things like that. And NLP models that are trained on this bias data will just exacerbate those biases. And in our pilot study, we showed that highlighting the dialect can actually influence the labels of offensiveness. But kind of tackling some of the themes that have been in the question so far, like maybe, given this situation, we should rethink how we tackle hate speech detection as a whole. And to hammer on this point even more, racial bias isn't the only bias or issue that is going on in toxicity classification systems. There's also this thing that we like to call lexical biases, which is basically that if you have a minority identity, your system is likely to flag it as toxic, more likely to flag it as toxic compared to if you have a majority identity in your text. There's also bias against swear words. So like if you say something positive, like I fucking love this, your model is going to flag it as super toxic. But if you say something that's really awful but doesn't have any swear words, your model might just not even realize that it's a problem. And just to highlight this a little bit, so in some recent work that we presented at EACL, we actually tried to see if we could automatically debias the racial biases and lexical biases in toxicity language detection models. And specifically, we asked, can automatic debiasing methods from NLI, natural language inference tasks, mitigate these biases? Because there's been a lot of work in debiasing NLI systems. For example, there's been things looking into ensemble model learning, as well as data filtering and things like that. And I encourage you to read the paper, but the short answer is that it's not that easy to debias these models, actually. And it's easier to debias if your biases are lexical, so like related to keywords, but it's actually a lot harder for dialect-based biases to be removed or mitigated in these systems.
Hi, Maarten. There is a question.
Awesome.
Hi, Maarten. Hello. I'm wondering, so for the different types of priming for dialect and race priming, I'm wondering, because they seem quite similar to me in terms of like in terms of conceptually as like part of the experiment. So also like the results seem to be pretty similar between them. So what is the significance of having both the dialect and the race? Because shouldn't one kind of entail the other?
Yeah, so I mean, it's kind of going back to like the question of like not everyone who is Black speaks AAE, and not everyone who's AAE is Black, who speaks AAE is Black. And also just in terms of lay people's knowledge of AAE, like I think most people in America know what a Black person is, but I don't think that, maybe 60, 70%. I don't know how, that's maybe too high. You know, I don't know how many people actually know what African American English is and or consider it like you know, a valid form of language. And so when we're thinking about these annotation tasks, like we should think about also like what is the knowledge that these annotators have. And so when we were doing the dialect priming condition, we gave them information about the dialects. But in the race condition, the race priming condition, we didn't have to give them that much information because people know what you know, race is broadly. So that's kind of the difference.
Okay, yeah, thank you. That makes a lot more sense. Thank you.
Sure. I wanted to, should I answer some more questions or what do we think? How many years are we away from a time where we may not need an army of human moderators for explicit content? I would advocate that we should never be free of human moderators. I think that letting AI systems, you know, remove or moderate things automatically is not the greatest option because that gives them power to silence us in a way that we don't want that. Does the race ethnicity of the annotator matter in these data sets? Since we are using these ground truth labels, how do we ensure the correctness of label quality with respect to different races? Thank you so much for a great segue into my next slide, which is talking about who decides what is offensive or not. And so I want a quick plug for our recent preprint that came out in November called Annotators with Attitudes, How Annotator Beliefs and Identities Bias Toxic Language Detection. And basically what we studied in this work is literally what you just asked about, which is the who, why, and what behind toxicity annotation. So basically looking at what is the effect of annotator identities and beliefs on their toxicity labeling behavior, as well as looking at what types of text they're likely to label as toxic more or not. And specifically, we did 2 controlled annotation studies where we collected attitudes about different concepts like offensiveness, or we asked them about like sort of racism. We asked them about free speech. We asked them about empathy and things like that. And we also collected their demographic information. And some things that are showing up is that racist text, so things that are really racist in meaning, are less likely to be labeled as offensive by people who already hold racist beliefs. Also less likely to be labeled as offensive by people who don't think that censorship should exist, for example. I don't fully remember what the demographic correlates are, but I'm going to assume maybe for racist speech, there wasn't that much of a difference. But we also found that African-American English tweets seem more racist to people who hold racist beliefs, which is also a really interesting finding there. And then finally, we looked at sort of the swear word piece of it as well. And what we found was that swear words can seem much more offensive to people who are more conservative, so politically conservative, as well as more traditional, rated as using a psychological traditionalism scale. Should I be following up on the discussion and the Q&A, or I'm looking at?
I mean, I guess you have to judge how many questions you can answer and how much you want to make progress. You're welcome to answer more of them.
Yeah, I mean, yeah. I think I could answer a couple questions. Are these models learning toxicity of tweet entries of a corpus that are labeled a priori or of any supervised learning, any corpus? I'm not sure I fully understand this question. Does identity of researchers influence how data sets are created and what's considered toxic, since the mainstream view by the construction reflects the majority demographic? That's an interesting question of like, what about the positionality of the researchers themselves? I think typically probably that influences things, but I think to sort of keep going with my talk here, like I think that really we should be rethinking automatic offensiveness detection totally. And, you know, just to really recap everything, like we know that there's a lot of labeling variation in these things, like what is offensiveness to whom, like it's really different depending on your background, your attitudes and everything. And, you know, even just the task phrasing can make a big difference. But also when we think about hate speech, like there's some countries that actually have like legal definitions of hate speech, right? And so we can't just go throwing around that term being like, this is hate speech when there's like legal definitions of this and legal implications of labeling something as hate speech. And then like the question asked, like, looking at the fact that annotators might operationalize a definition differently, NLP researchers might have different views of what, should go on in there. And I think that one big component is that, no one's asking the real question of like, why is something hateful or offensive? Like everyone's just like concerned with labeling and noise and annotations, but like, why aren't we focusing on like, what about the text is like making it offensive or hateful? And also just to hammer this point home that I've already mentioned, like, I don't think that, personally, my position is that should we really have AI systems making these decisions alone, like risking removing entire swaths of dialects, of content, moderating that. Like, I'm not sure that that's really what should be going on. So what if AI systems were designed to help humans determine toxicity by explaining why something might be toxic or biased instead? And this is going to be the next part of my talk, but let me look at some questions real quick. Okay, for the bias evaluation, the data system must have re-annotated to not classify AI tweets using slang as much as the N-word is not offensive. If models were trained on this re-annotated data set, does that mitigate the issue? In other words, wouldn't the NLP models learn that the N-word is only offensive in non-AE dialects? Yeah, so we actually did, in the challenges in automatic debiasing paper, we did do a translation experiment where we basically tried to translate the AAE tweets into like non-AAE English. And that was like the most promising direction. Basically, when you sort of like remove the markers of AAE, but try to preserve as much of the content and sort of use those labels there. But then the issue is that you have to relabel those you have to relabel those in sort of a context of their non-AE versions. So that sort of adds data to data annotation to the challenge. It seems like a lot of the classifiers right now are very lexically focused. Is there a way to make the model more contextually aware? Yes, and I think that's something that we should be focusing on more and more. And I'll talk about that in some future work. Seems like the model is picking up on raw tokens such as swear words. Would you go without to identify what does the sentence talk about? Yes, so that's kind of also what I'm going to talk about in this next part. I think I'm trying to like take care of these questions. Let me rephrase my question. How are these toxicity classifying algorithms learning what is and isn't toxic based on labels, right? And that's kind of the issue is like if the humans are labeling things improperly because they're flagging just words, then the models are just only going to be able to recreate that behavior. I hope that there is going to be potential regulations coming up towards this kind of regulating what AI systems can and can't do. But that also requires like tackling the fact that tech companies have a lot more freedom in the US right now. Okay. Is it possible that developing a model that detects a person's identity through this tweets has some potential privacy issue? How to mitigate the potential harm for use? Yeah, so I think that language, unfortunately, kind of is a way to communicate your identity to people. And so like that's what sociolinguists talk about when you sort of do code switching between your family and your work friends. Like you are sort of asserting a common shared identity or creating a common shared identity between your family and you in that one sort of dialect or way of speaking. And if you're speaking to your coworkers, maybe you're going to use a different type of way of speaking. And so like, sure, maybe like no one should be, spying on you and looking at like, oh, you're speaking to a coworker versus not. But if people are tweeting in these settings, then they're giving away a little bit of like who they're tweeting to and things like that. So yeah, when it comes to like studying these kinds of things, it's hard to disentangle, or it's hard to do without knowing actually like who the identities of the people are in the network. But it's just not as simple as sort of like your behavioral patterns might not give away as much of your identity markers as language can. All right, I think I'm going to walk through some more slides a little bit first, and then we can look at the questions some more. But if there's anything really important, please let me know. All right, so we talked about the problems with classifying toxicity or toxic language. So I want to talk about social bias frames, which is actually what I would like to call like a new alternative way of looking at this problem, or the first iteration of that. So social bias frames is a new formalism to reason about the social and power implications of language. And I know that we've been talking about hate speech and stuff like that already, but I want to warn you that the content in this, the rest of this talk may be upsetting or offensive because I'm going to show some examples, unfortunately. And again, just to contextualize this a little bit more, we're approaching these problems of social biases from a US social cultural perspective in this project. And this is actually work with another Stanford professor, Dan Jarofsky. Okay, so when we think about social biases, there's two ways that these social biases can be expressed in language. First one is we should kill all XYZ demographic group. And this is super easily flagged as toxic by your off-the-shelf toxicity detection systems. But there's a much more subtle way of expressing social biases. For example, in the statement, we should lower our standards just to hire more women. And so we can all here understand that this type of unconscious bias here, this because of how language implicature works, like this is implying that women are less qualified than men, especially because this just word here is really hammering that. And so we can understand that this is an unconscious bias, but it's not flagged as toxic at all by these models, unfortunately. And so this motivated our creation of social bias frames as a new structured formalism that distills knowledge about the harmful or biased implications of language. And so specifically, this is kind of a structured formalism. So let me walk you through the structure. So if we have a post, we should lower our standards just to hire more women. We're going to ask annotators, like, is this offensive or not, as a sort of pre-screening round. We're going to look at, was this, do you think this was intended to be offensive or not? In this case, maybe. We're going to ask, is this a lewd statement or referencing something sexual? Not really here. If it was annotated as offensive, we're going to look at, is this targeting a group of people or referencing a group of people, or is this really just an individual insult? If it is a group of people, we're going to ask for a free text explanation of who that group of people was. In this case, it's women. And then we're going to ask for a free text explanation of what is the implied stereotype here. And this is that the stereotype that women are less qualified than men. And then finally, the last variable in our frame is related to in-group language, which is about sort of capturing whether the statement is made by members of the same group as the group that's targeted, kind of trying to address this sort of speaker and listener identities. But here in this case, that doesn't really seem to be the case. So again, to remind you, the motivation for social bias frames is really that if we want to be able to avoid like problematic or really if companies want to avoid PR problems of their chatbots turning racist, they need an understanding of what they actually want to avoid. And social bias frames is a new view on this what to avoid or these social biases. And it's more explainable and trustworthy because it comes baked in with explanations of like why something could be biased. And it's more holistic than binary hate speech detection because it gets around like, are you, offended by this statement or not? And really, it's trying to distill like what is the offensive meaning behind this, which is different. I also want to highlight that in order to study these social biases in the wild, we created the social bias inference corpus, which is 150,000 annotated tuples that were labeled from 44,000 posts from social media, including from Twitter, Reddit, the neo-Nazi communities of like Gab and Stormfront, as well as some banned really misogynistic subreddits. And our corpus contains like 34,000 implications about 3,000 different demographic groups. And I don't have time to go into the details of how this was created, but because of how we trained our mTurkers and our annotators and how we selected them, we actually got pretty high pairwise agreement on this, these annotations. And also, we really wanted to be able to capture the types of discrimination that people are actually reporting experiencing offline or or online, but in the real world. And so we're not just capturing like sort of fandom wars or pop star fandom wars, but we're actually capturing like hatred towards demographic groups that are reflective of real world discrimination. Also, I wanted to highlight the way that we designed this frame inherently had interdisciplinary sort of knowledge in mind. And so we really tried to ground this in social science literature, specifically looking at literature of rudeness, pragmatics, offensiveness, and how people sort of perceive offensiveness and things like that. And this actually led to the inclusion of this intent variable, which is not only there because if you sort of perceive someone as being well-intentioned, you might be more forgiving towards what they're saying, even though their bias is still there. But also, if we think about implementing these tools to give feedback to people who are writing text, and if your AI system tells you this is 80% toxic versus, hey, you might have not intended to be offensive, but here's like what you're thing implies about this group of people, that could actually be a much softer feedback to an author. Also, as we've discussed with the AAE racial bias case, like we wanted to include situations where things were cases of language that's more in-group. So that's things like self-deprecation or reclaimed slurs that can appear offensive if you're not a member of a group, but if you are a member, it could be less offensive. And then we also wanted to be a little more intersectional. So we wanted to have the ability for posts to target multiple groups at the same time or multiple identities. And so we collected that. And we also collected multiple implications to get more data for the kinds of stereotypes that are there. And then finally, the way that we designed this frame also had in mind the sort of annotators to see like what can and can't be done at scale. I see a question. How accurately can AI detect intent from text, if at all? I will answer that in a second because we're going to look at some results. What about AE or models finding offensive? Is it mainly use of the N-word? Actually, if you go, sorry, this was a question for before, but if you go to the appendix of the racial bias paper, we have like the most common features that are used by the classifier to determine things and plotted by likelihood of AAE. You should take a look at that and it will answer that. So it's not just the N-word, but it also is like suffixes that appear in words and things like that. Okay, I think the other two are like maybe a little bit longer, so I'm going to answer them later. Okay, so given that we have a corpus as annotated with social bias frames, we wanted to know like how good are NLP models actually making inferences using social bias frames. And so we set up a case study where the goal is to predict an entire social bias frame from a previously unseen post. And in order to do this, our model requires classifying these categorical variables of like intent and offensiveness and things like that, but also it needs to be able to generate the groups and implied statements. So not all models are able to do this, but GPT style models actually can do this if we set them up correctly. And so the way that we did this is we took our social bias frame, and there's some cool animation, so watch out. And we linearized it, adding special tokens for each classification variable. And then we passed them through a transformer-based conditional language model that we had initialized with GPT-2 in this case. And then we optimized the negative log likelihood of all tokens for training. And then for predicting social bias frames, we are going to frame this as like a conditional generation setting of the linearized frame, token by token, sort of sampling it. But can anyone tell me if there's anything wrong with the generated frame right here? So actually, there's a big problem here that the post was predicted not to be offensive, but still having implications about Black folks. And this is a problem here where generated frames can sometimes not be consistent with the frame structure. And this is because when you linearize, your model can sometimes just not learn the full structure properly. And so what we need to do is enforce the structure post hoc. And so I'm going to gloss over the details here, but basically you can either just kind of like top down enforce it, or we can do something a little bit more global and let your future decisions correct your past mistakes a little bit. And we see a little bit of difference that this constrained sort of more holistic inference helps. But sort of answering the question of like how well can models, how well do models do at these different classification variables? Well, it's maybe okay to predict whether something was like intended to be offensive or not. But what is really much more challenging is predicting whether something is targeting a group or an individual, as well as predicting whether something is in-group language, which is just really hard to do, especially given the data that we have. But more interestingly, like the performance of how models are able to generate the implications is actually interesting to look at. I'm going to gloss over the automatic sort of metrics of this here. But the model's able to identify the right targeted group like actually pretty well. But the bias implications are a lot more challenging to generate, which I can illustrate with an example after answering some more questions because I'm seeing things pop up. Posts from fandom/stan Twitter might be overly offensive for comedic effect. Ethically, should we be concerned about these types of posts? Yeah, so that's one of the reasons why I think it's important to think about like who's being offended or like what is the implication here. And like I'm a big believer that we should tackle like important problems. Sorry, stan Twitter, but like people aren't dying or being like killed because they're a Selena Gomez fan. However, people are dying because they're, a trans woman. Like that is, one of the highest murder rates in the country. So trans women of color specifically. So like, that's the kind of biases that I think our AI systems should tackle. And like capturing arguments between political parties online, like isn't that important in my view. But that's why, and but these type of informations of like who's actually being targeted, like who's being harmed, that wasn't there until social bias frames appeared. Like no one thought about this kind of stuff before. They were just like, oh, this is offensive or not. And so you end up just putting the same, anti-Semitism in the same bucket as like anti some pop stars fandom sort of arguments. So I think that's a really good point. How are the free text responses processed in the model? So it's literally just token by token. So it's kind of like language modeling, conditional language modeling. I maybe would refer you to the paper for a little bit more detail, but it's like really just word by word. Why is a generative method used to detect the frames rather than a classification model? So we have to generate the implications. Like those are literally just like open-ended strings. So we can't just use classification, and we could just do separate, like, classification first and then add a different model, but that would just, I mean, I encourage you to try if you want to, but that may work about the same potentially. Okay, so let's look at some examples. Again, so warning, there's some offensive content here. All right, so here's an example from the dev set of social bias inference corpus that says, I love gay guys, they're so much fun. I would love to have a gay guy best friend, but lesbians are just annoying. So the model here predicts that this post is offensive because it implies that lesbians are annoying, which is basically just written there. And this is in line with what the annotators wrote, which is that this post implies that lesbians are annoying. But the annotators also wrote that this post implies that all gay guys are fun to be around. And so this illustrates the kind of mistakes that this model tends to make, which is that it can typically be successful when there's really verbatim cues, but they struggle with more subtle biases. For example, the positive stereotype that all gay guys are fun to be around. And social psychologists tell us that these positive stereotypes can have also nefarious effects on people, even though they're not negative in sentiment. Another example here is about a Black guy who's in class and throws a paper ball into the trash, and his teacher says that he's a disgrace to his race. The model here predicts that this post implies that Black people are trash, which is not what the annotators wrote. And in fact, the annotators here correctly flag that this post implies that Black men are defined by their athletic skill, or that all Black men should be good at basketball. And again, this is an example of where a model might be relying on negative keywords more and finding the identity-based words as well as the negative keywords and just combining them and assuming that that's what the implication is. And so this kind of keyword-based reliance is not, sort of only specific to this task. Like there's a lot of places where models tend to rely on lexical cues a lot more, but yeah, so we need some new modeling advances to do this task better, probably. So just to summarize this real quick, so social bias frames is a new formalism to distill the harmful or biased implications of language. We introduced a new data set with annotations, and then our experiments show that models really struggle with these more subtle bias implications, which motivates, as I said, the need for better structured reasoning about social biases in people and groups in language. So at a higher level, though, the goal of social bias frames was basically to create an interpretable or explainable formalism that could represent social biases in language. And these explanations can be really useful for determining, what's already what's going on in already written text. So, for example, I'm imagining social bias frames as being helpful for helping content moderators make decisions. So not just having the text, but also having like the implications. If our models were good, having implications of the posts be associated with there, and people could have make a more informed decision about moderation. It could also be really useful if you're sort of looking at like a corpus of data that you're interested in quantifying, like, how much sexism is appearing in this corpus, then you could sort of do that with these kinds of explanations. But what I'm really excited about too is that these explanations could actually help authors as they are writing text by pointing out the maybe unintentional biases in their text. And so this opens the door for debiasing text through rewriting, which is the next part of this talk that I'm going to talk about in the final project. But I will answer one more question real quick. This is not a technical question, but I tried to develop models to filter out offensive content, but had to give up because it was mentally exhausting to see the offensive content myself. Yes. What do you think is the best way to protect the researcher and annotators themselves from the effect of harmful target data set during research? Could you share any personal tips? So I think that personally, I am just kind of used to staring at this data now. So I'm maybe a little bit less affected by it, because I think that there's something empowering about knowing that I'm doing something about the issue. So that makes me a little bit less sort of affected by it. When it comes to annotators, I always, I think I always try to align their motivations with the same goal. Like, we're trying to make the internet less toxic. Like, we're really trying to make a difference here, and that's why we're doing this. We're not just, displaying these awful things to you for, a fun purpose. Also, like, try to take breaks. I also have, extended experience being in therapy, so that helps. Having a support system and things like that. Just really not approaching this from a place where you're already vulnerable. But if you can sort of have a support system and take breaks and things like that, that makes it a lot easier to do this kind of research. But like I said, I think there's something just like kind of empowering about knowing that I'm, trying to tackle an important problem. Okay, so let me talk about this last part of the talk, which is Power Transformer. And so Power Transformer is an unsupervised controllable revision model for biased language correction. And what I mean when I say biased language correction here is we're looking at bias through the lens of connotation frames of power and agency. So what these words mean is basically connotation frames of power and agency are a common sense formalism that I introduced in 2017 with my co-authors. And it distills knowledge or connotational knowledge related to verbs or verb predicates. And specifically, so for example, if you have someone is pursuing something, this connotation frame is going to distill knowledge about the power differential between the agent and the theme of the verb, so the object and the subject of the verb. So in this case, when someone is pursuing something, it's kind of likely that the person doing the pursuing has less power than the person that they're trying to pursue, but they're not able to get. Also, the connotation frames capture notions of agency that is attributed to the person doing the action or the event. And so in this case, someone who's high agency is someone who tends to be very decisive, active, driving change. So someone who is pursuing something is like really driving that change of like pursuing the thing. But also someone who's wiping, beating, fighting, shooting, scarring, things like that. Versus someone who's low agency tends to be very passive and experiencing events. So that's maybe someone who's doing more tripping on things or sleeping or viewing or dozing or dreaming, things like that. And so we can actually use these connotation frames to analyze all sorts of texts. And specifically in this original work in 2017, we analyzed the way that characters were portrayed in movie scripts, modern movie scripts, I should say. And we wanted to study basically the agency levels of characters with respect to their gender. And so just glossing over the details here, but what we found is that in these modern movie scripts, men were portrayed with much higher agency and women were portrayed with much lower agency, unfortunately. And again, this is an example of what I call the cycle of social inequality in text, because in the world, men unfortunately have more societal and decision-making power than women. And this in turn then, transformed it. And when we're writing text, we tend to portray women as less agentic and more powerful than men, because it's just kind of how the world works. And so then when we read these texts, this reinforces our perceptions of gender roles and stereotypes, and could just continue this cycle. But this motivated our new task of controllable debiasing, which basically is asking, can machines learn to revise text to debias these portrayals and essentially break this cycle of social inequality in text? And so specifically, the goal of controllable debiasing of our story sentences is to take in a sentence like May daydreams of being a doctor, where May is portrayed in very passively with low agency. And we're going to rewrite it to May pursues her dream to be a doctor, where May all of a sudden has much higher agency than before. So there's actually two challenges to doing this kind of thing. The first one is that contrary to some existing sort of work on rewriting, we cannot just paraphrase the sentences, because a lot of times the biases are actually not just in the framing of the actions that are attributed to characters, but actually in the actions themselves. And so on the other hand, we also want to avoid making unnecessary meaning changes and completely rewriting the sentence. So we want to preserve as much of the meaning as we can while also still debiasing. And so what you want is targeted edits with minimal meaning change. A second challenge is that this is essentially an unsupervised task. And what I mean by that is that there's no parallel input-output pairs that can show a model like this is exactly what you should rewrite this sentence to. And so the way that people have tackled this problem before is using generator discriminator models by basically setting up like a discriminator on top of your generation model and kind of like GAN style things. But oftentimes research has shown that this leads to really disfluent or less grammatical output text. And so our approach is we're going to follow Lee et al.'s approach of masking and reconstructing sentences. But in order to really do this fully, we had to add two novel modeling aspects to this. The first one is we added an additional paraphrasing training objective. And then at testing time or at generation time, we're going to add a vocabulary boosting mechanism to reach the desired agency levels better. All right, so let me walk you through the way that Power Transformer is set up. So the way this model works is we start with an input sentence, like May daydreams of being a doctor, and a desired agency level, in this case, like high agency. We're going to mask all the agency markers from the input sentence using our connotation frames. We're going to transform our desired agency level into a special token. We're going to feed those into a transformer-based conditional language model. In this case, initializes GPT. And then at training time, we're going to use our joint reconstruction and paraphrasing objective. And then at test time or at generation time, we're going to use our vocab boosting mechanism on top of the probabilities that are given to us by the model to even further reach the desired agency level. So to be a little bit more specific, the joint training objective has two parts. The first one is an in-domain reconstruction objective, which takes in sentences from our story corpus, masks the agency markers, and then optimizes the log likelihood of the reconstructed sentence. And then the second one is an out-of-domain paraphrasing objective, which basically uses pairs of paraphrases from TV subtitles, so very different corpus, very different domain, and then optimizes the likelihood of a sentence given its masked paraphrase. And then the way that our decoding time that our vocab boosting mechanism works is essentially it's going to increase the likelihood of tokens that are connoting the right desired agency levels. And we're doing that by adding a vocab size vector to for the right agency levels at each decoding time step. So basically, like every time we generate a new word, we're going to shift the probabilities up of the words that are kind of in the right direction of the right agency. And then we can do this shifting at different strengths using a parameter beta here. So there's a lot of different components in this model, right? So we can actually wanted to measure whether all of these components actually mattered. And just doing some ablation studies where we looked at whether the vocab boosting actually helped or reconstruction or the joint objective and things like that. We actually do find a performance gain from both the vocab boosting and the joint objective, looking at whether or not we reach the desired agency levels. So just in terms of accuracy. But this is a kind of open-ended generation task where we have an input sentence and an output sentence that could look like a lot of things. And so we don't really have good automatic ways of evaluating this kind of open-ended generation task. Unfortunately, as of today, it's really still an open problem. If you're excited about evaluating text generation, I encourage you to work on it because it's really exciting. But unfortunately, until we have a really good text evaluation system, we tend to rely on human evaluations instead to tell us like how good these outputs are. And so that's what we did in this paper. We designed a head-to-head evaluation task where we basically gave the raters the output of two systems and then asked them which one better preserved the meaning and which one better preserved the agency compared to the original sentence. And we actually compared our full Power Transformer model's outputs to the non-boosted version of the model, as well as two baselines from related tasks, but different tasks. And what we find is that both Power Transformer models actually are better at preserving the meaning than the previous baselines. And then the full Power Transformer model with the vocab boosting actually has more accurate output agency levels compared to the other baselines. So given that we have evidence that our model actually works well, we wanted in this paper, in this project, to circle back to the movies scripts that I mentioned earlier, and then see how Power Transformer can help actually sort of mitigate these biases. So as you recall, in the original movie scripts, we found that men were portrayed with higher positive agency than women. And so we're going to do a case study where we're going to rewrite the lines that describe female characters using Power Transformer, specifically trying to give these characters more agency. And so in the revised scripts, what we find is that not only do women have much higher agency than before, but if we compare the gender effects, actually, all of a sudden, women have much higher agency than male characters, statistically significantly so. So these coefficients look really big, and I want to sort of give a caveat here that this is a very broad swath approach to de-biasing language, because we rewrote every single character that was detected as being female. But I think here what this actually illustrates is the promise for using human AI collaborative writing setups to help people maybe write less stereotypically. So kind of enhancing this writing sort of platforms or these tools that people are using to write to give them more information about how what they write might be perceived. So, glossing over the contributions of Power Transformer here, we introduced the new task of controllable de-biasing. I talked about these connotation frames, which are a new common sense formalism, and then introduced a new model, Power Transformer. And we showed in the case study that we could actually mitigate, automatically mitigate some of the gender biases in movie scripts. And so this concludes the last sort of part of my talk about projects. And I wanted to briefly walk through some future directions, and hopefully we can get some more discussion going as well on that. I know that I think I have about 15 minutes left. So to recap, like in this talk, I talked about racial bias and hate speech detection and proposed some race-aware annotation strategies to maybe mitigate this. Then I talked about social bias frames as a new way of even viewing the problem of hate speech detection by looking at the bias and harmful implications of language instead. And then finally, I showed with Power Transformer that we can revise and debias text through the lens of connotation frames. But there's a lot more to be done towards this sort of broader goal of avoiding and mitigating biases in language with more human-centric models. And so I'm really excited about furthering this research on understanding how social biases show up in human written language. So this requires looking at how we can do better at detecting social biases and toxicity in language. So I'm really excited about working more on developing formalisms for contextual bias representation. So harkening back to a question that was there earlier. So for example, a lot of these representations have ignored the conversational context in which things appear. And actually the pragmatic implications of conversation in terms of biases are actually not trivial to capture. For example, you could say something really offensive and then someone else could say, oh, I agree. And then, of course, the first utterance is offensive, but then what do you do about the second utterance? Like knowing the stance towards offensive utterances is also really important. And so we studied that a little bit in a work called Toxicity that was published at Nlp 2021. As I showed, there's a lot of differences in terms of like who the speaker and listener and annotators are when it comes to these kinds of sort of social biases in language. And so we need to keep looking at like how those identities and the power dynamics between those identities affect the implications. Of course, our social bias frame model wasn't perfect. And so we need better models to do better, deeper reasoning about biases in text. And as I mentioned, I'm really excited about this whole sort of application of rewriting text to debias it. And so potentially using other dimensions than the connotation frames of power and agency, but maybe using social bias frames instead, things like that. And this also requires studying how humans would react to these kinds of inputs from models. Like, is someone going to be more or less offended if a model says that their text might be biased versus a human would say that? On the flip side, I'm also really interested, and I think it's really important to keep looking at how we can avoid biases and toxicities in machine-generated language. And so, I've done some work on scrutinizing the biases and toxicity in these pre-trained language models. For example, looking at how quickly a language model could generate toxicity, but also how what about the pre-training data and the way that pre-training data was selected affects the types of biases and toxicity that is in these machines. So for example, in some recent work, we found that I think that was published at EMNLP 2021 as well. We basically found that like, the African-American English was really likely to be removed from automatic sort of data quality filters that Google uses for their corpora. So there's some problematic things about that as well. Also really excited about, finding ways to steer methods that are that can help avoid toxicity. And so this is kind of also harkening back at the earlier question of like, what about the pre-training data or the training data versus like the test time sort of behavior of models. And like I said, I think we should tackle both, and I'm really excited about tackling both these things. So how can we steer models that are already trained and we know that they may have toxic behavior? How can we steer them nonetheless to be less toxic? So we have some work called Dexperts, where we basically learn from the worst in a way, where we basically have a really, really toxic LM that is an anti-role model for the standard language model. And so it's basically like your really, really racist uncle. And so if you know that your racist uncle would say it, then you know that you shouldn't say it, basically. And I think in terms of like looking at steering these models and avoiding toxicity in machine generated text, like we should think about, expanding what we should avoid, and not just avoiding swear words, but also, maybe we want our models to be pro-social, and maybe we want them to not violate social norms in general and just follow community norms more. And specifically, maybe we want to allow for personalization so that it's not just one culture that's being represented in our machine language or machine learning models, but could be personalized to your own culture and things like that. And then finally, I think there's, I'm really excited about bridging the gap between NLP and social sciences in general. So, asking what social sciences can do for improving NLP systems. So for example, looking at how psychology and sociolinguistics can help us understand how people label or perceive offensiveness in text, but also in general, how can cognitive science findings help us understand how cognitive biases might appear in cross-sourcing tasks in general. And then the converse of using NLP to answer social science questions is also really interesting. So for example, we know that misinformation in news is another big issue that's going on online, where people are sharing misinformation or propaganda. But can we make machine learning or NLP systems that can help us fight this by, for example, distilling common tropes that are evoked by headlines, or producing or generating the sort of likely reactions that someone would have to a headline, so that we know when someone's really afraid that maybe we should be careful about framing something in a very fear-mongering way. And in general, creating methods for analyzing social phenomena in text is also really important, so that we can answer social science questions for that. All right, that concludes my talk, and I'm really excited to have been able to share my work with y'all. And I want to thank you all for listening. And I specifically also want to thank my collaborators, because without them, none of this work that I just talked about could have been possible. And I'll take more questions now. I'll answer questions. So in places where keyword censorship is enforced, I observe that people change how they speak using code words or acronyms to avoid censorship, but fundamentally it is not that effective in actually preventing people from talking about it. Hate speech detection is of course more complicated and harder to evade. Do you think that over time maybe people will still find a way to avoid it and render the whole system ineffective? Yeah, absolutely. And this is kind of a dual use question too, because like some moderation is really meant to protect people. For example, there's work from, I think it's like sort of HCI people that looked at the pro-anorexia communities online. And there's a constant battle of people that are sort of trying to get people to become more anorexic, learning new ways to promote the hashtags and things like that. And then the platforms and the moderators like sort of falling behind and just like trying to follow and like being like, okay, this hashtag now means this and things like that. So like in the grand scheme of things, it's like, well, shouldn't we moderate this? And so it's definitely a tricky question there. But yeah, I think if we can tackle at least like if we can set a rule around the biases that we want to moderate, like there's always going to be people that are going to try to evade it. For sure. Yeah, that's kind of, yeah, I think that I don't actually know if there's a good answer for this question. But that's a really astute observation for sure. Okay, said something. I'm curious, there's such a thing as kid-friendly or kid-aware LM. Kids are spending record time on devices online. This is certainly a governance issue, but how do you incorporate ages into the model to make technology truly user-friendly? Yeah, that's hard, because like who decides what's appropriate for kids or not, right? There's a anti-gay bill in Florida that's trying to be pushed, where people don't want to talk about homosexuality. That's a very political stance, because like there are kids that are gay and struggling with that. And so I just want to raise more questions, honestly, because I'm not going to pronounce myself on that. I don't know that. I think that protecting children is oftentimes a reason that is used as an excuse to justify censorship and other things. So I think we should be careful about that kind of argument, though. Like, are we actually looking at what is actually harming children, and like what are the biases of those studies versus people just being morally outraged by something and saying that their children should be protected from it instead. So it's not clear. And also, I think in general, we should be really regulating the usage of AI and technology for children, because we do want to protect them from things, that's for sure. What techniques can be used to detect social biases, hate speech in languages that we don't have large curated labeled data sets for? That's a really good question. I don't know that it's that possible. I mean, there's this sort of low resource language approaches that people would use. Maybe multilingual transfer type things could help. But like, I think with these kinds of things, like I'm more interested in like what the humans that are being affected think. And so we would need some sort of information about what they like and what they don't like in order to be able to tackle these undesirable language that we're trying to remove or detect. I wonder if you've thought about some of the potential risks or ways in which this type of work could be misused. Yeah, so people talk about dual use a lot in this case. So the issue is that like Pandora's box has been opened, the internet exists, and it's just rampant with hate speech right now, and it's pushing people out in a lot of ways. And so not doing anything about that problem is kind of an implicit endorsement of the fact that minority people are being pushed out of these platforms or are being silenced by these algorithms. So like, we don't really have a choice to just go back to a world where this isn't an issue and we can just pretend like it doesn't exist anymore. I like to work on making things a little bit better because I think that people are, being censored, and that's not wrong. But like, it's totally valid if you would rather not work on it because you're afraid that your technology is going to backfire you even more. That's for sure. But I think like there's no good sort of like, we're already kind of in an ethically bad situation, unfortunately. So I've definitely thought about this a lot. Okay. Have you faced any opposition in applying your research in toxicity detection? Yeah, so kind of same question. Like, I think people get really freaked out that they're going to get censored. And it's like, the answer is that people are already being censored. Maybe it's not you, but there's already people being censored. So like, again, cat's out of the bag. Like I don't think that it's like we're developing technology that is just not solving a real world problem and just creating more problems. Like internet is already existing. And so social media exists. And we should keep working with legislators as well to like prevent people from overstepping the power that they have. So for example, I think considering social media platforms like not like what a company can dictate everything on, but considering them like public forums, and sort of having regulations around like what can and can't be said in public forums, and looking at those and seeing what applies to social media platforms is important. Would you rather have Turkers, labelers for offensive and offensive text incorporated be more or less ideologically, culturally congruous? What metrics should we use to disqualify someone from labeling text, if any? Yeah, so again, that's where positionality of researchers comes in. Like, I didn't want to create a data set that was all about flagging anti-white statements, because that's not a technology that I believe is reflecting the actual harms that people are experiencing. If a researcher wants to do that, they're free to, I can't control what they do. But I think, yeah, this is kind of a part where like any technology that we develop comes from a place of like our own biases and our own positionality. So we have to recognize that no matter what we do, right? And it's not just because we're tackling something that's politically charged all of a sudden that that's the only cases that these kinds of positionality things affect our research.
And we have a live question.
Hi, thank you for the talk. It's really enlightening. I was wondering, there's always going to be a gap between the values of the model builders and the values of the people who are using these models. And what do you think we can do in like creating some sort of system where these values will constantly evolve, we're constantly changing what we think is moral and not moral, biased and not biased, And these values sort of evolved over like thousands of years, but now with AI, they're sort of evolving over minutes and seconds. Like, are there ways to sort of make sure we come up with a good set of values, but can adapt to kind of the changing values of like people who are using the models as well?
Yeah, I mean, I think like ultimately like our approaches should be more human-centric than they currently are. And like looking at, who the stakeholders of this technology are, and like we're just really starting to scratch the surface only of like bridging that gap between like the developers and like the people that are being affected by this. And so we need to keep doing work just like uncovering that link and like how people are being affected and like looking at what those people want, and doing that kind of like value sensitive design, like looking at like what the communities that are actually going to be affected by this technology want out of it. But just like any technology, like nothing should be static. And if the world changes, like we should be changing our technology with it as well, to adapt with it. And so, yeah, it's kind of a non-answer because it's like, yeah, we should just be, talking to people and asking them and getting out of the just NLP part of it and just really going to the users and asking them like, what are they experiencing?
Thank you.
Okay, so asked, how is agency and power transformer actually quantify a character to be positive or negative? Are these based on actions, intent, emotional strength of characters being portrayed? So it's about the verbs that are being used to describe these characters. So that's how we measure the agency of a character, basically. So like, are they doing a lot of chewing or are they doing a lot of sleeping, basically, to simplify. And there's, it's just the lexicon. So you can download the lexicon and look at it as well. In all the current social media platforms, images also play a crucial role, more like a combination of image and text, very important for detecting hate speech or other biases. Do you plan to explore? Yes. Yeah, I'm really excited. I'm actually meeting with some OpenAI folks next week to talk about multimodal sort of like toxicity detection and things like that. That's a whole other ballgame. Unfortunately, my training is in just language, so I don't really have a lot of expertise in vision, but I'm really excited to try seeing how that works. There's still a lot of places where it's just text only though, so I'm confident that I'll still have some work to do just in that. Thank you for amazing sharing. My question is how to keep social bias models we've talked about in this lecture updated to the social. Okay, so that's kind of what someone else asked as well. Just, I think that's the answer. We just need to keep updating things and just, not think of models as static. And if we can make our models be able to be conditioned upon a large set of rules or things that we know are problematic, or and we can update that, then our model can inherently be updated just by having the new data accessible.
So we have gone to 4:45, Maarten.
Okay,
I mean, it's up to you if you're just powering through and want to answer a couple more questions. You're welcome to, but you're also welcome to take a deep sigh and stop.
I feel like I'm just like, I want to answer everyone's questions because they're all so good. But I should probably stop here just in the interest of time and being respectful of everyone who can't listen to all the other questions. But this was great. I'm really excited about all the questions that we got. It's been a minute since I've been like, interrupted in the middle of talks for questions. So I wanted to answer all of them and try to get through everything. But this is awesome. Yeah.
Well, thank you so much for giving this talk and your rich insights into the area.
Yeah, of course.